In this video, we're looking at the gradient of a straight line or a linear function. So the gradient of a line measures its slope, so how steep it is. It compares the vertical rise, so how far it's going up, with the horizontal run, which is what it's going across. Most of you should have heard of this before, but the gradient is represented by m, and m usually equals rise over run, or if you want a more precise equation, it's y2 minus y1 over x2 minus x1, and you use that when you're given two coordinates and you label them. So remember, gradients can also be positive, so they're an increasing, or negative, so they're decreasing. So if an increasing graph will look like this, so as we go towards the right, it's going up. Then a decreasing graph will look like this, it's going down, so as we go to the right, it is going down. Increasing, going up from left to right, decreasing, going down from left to right. Next, I'm going to show you how to use the formula. So here in our example, we have a gradient of the line we need to find, and the 2 points we were given was -1, 3 and -7, 7. So what I like to do is write those down first. I'm just going to leave some space. So -1 and 3, and we also had -7 and 7. And what I like to do then is label them. x1, y1, x2, y2. And we remember that m equals y2 minus y1 over x2 minus x1. So all I do now is I'm going to substitute those in. So my y2 is 7, so we have 7 taken away by y1, which is 3, over x2, which is -7, take away x1, which is -1. So what we get here is 7 take away 3, so that becomes 4. Then we have -7 take away -1, so that becomes a positive. So this here becomes a positive. So we have -7 plus 1, so -6. And then simplify where we can, so 2 over -3, or -2 over 3. So that would be your gradient. Okay? Now, because it's negative, we know it's actually going down. Okay, so if your gradient is negative, it's going down. If it's positive, it's going up. The next thing we're going to look at is gradient and what we call the angle of inclination. So the angle of inclination is the angle of a straight line that it makes with the positive axis. So if I have my grids here, my axes, and then I have some sort of line, this here, this theta, is my angle of inclination, right in there. Okay, so that's our theta. So here in our example, we need to find the gradient of a straight line whose angle of inclination is 82. So it's pretty straightforward stuff. Write down your formula. And what we're going to do is substitute that in. So m equals tan 82. And you put that in the calculator, and in our example it comes out at 7.1 if we're rounding to one decimal place. Now if you were given m first, you would need to find inverse tan. So if we were given, let's say, 7.1 equals tan theta, we would go tan -1, tan -1. So theta would equal inverse tan 7.1, and that'll get us approximately 82 degrees. The next thing we're going to look at is what we call the gradient intercept equation. I have spoken about it in the past, but for a reminder, it is y equals mx plus c, where m is your gradient and c is what we call the y-intercept, where it crosses the y-axis. So it's fairly straightforward. So here in our example, we need to find the gradient and y-intercept for fx equals 2x plus 1. So in this case, remember, fx is the same as having y, so I could rewrite as y equals 2x plus 1. In blue, I'm going to write our formula, y equals mx plus c. So m must be 2 and c must be 1. So the gradient is 2 and the y-intercept is 1. Here we have a different form. It's in the general form. It's a little bit harder to distinguish what the y-intercept and the gradient is. So what we do here is we're going to rearrange it. I want the y to be positive. In this case, it already is. So I'm going to go minus 5x minus 5x. And I'm left with y plus 6 equals negative 5x minus 6 minus 6. They cross out, and I'm left with y equals negative 5x minus 6. You can have gradients for the fractions for the gradients, just so you know. It can be a fraction there, and that's okay. So in this case here, my m is negative 5 and c is negative 6. Sometimes doing this, you'll end up with something similar to y equals, let's say, 2x plus 3 over 5. And you're looking at that going, I'm not sure what my gradient is. A good practice is to break it up. So we get 2x over 5 plus 3 over 5. So in this case, the gradient here would be 2 over 3. And the y-intercept would be 3 over 5. So it's important to note that you can break that fraction up into two parts.